Hello ETL enthusiasts, welcome to this presentation. It's all about Informatica interview, how to pass the interview and what needs to be. This is like a guide, okay? So first part is already uploaded. This is the second part. This is also a little longer, try to be patient. And I tried to explain each and every topic clearly. If you have any questions, you can have it in the comments, okay? Let us start with the agenda. Informatica interview expectations, as I already explained in the first part, five sections are there. Okay, three are mandatory. Okay, two are optional for interviewer, not for the you. Okay, so current project and basics both were explained in the first part. So let us see. Today's presentation is all about Informatica Power Center. Okay, so let us jump into the slides. First one we'll discuss about lookup. Lookup transformation is very important to the interview. I should say that without lookup, there won't be any interview. Okay, so that's why it's very important. Let us start from there. In lookup, we'll see what is a lookup, uses of the lookup, caches, and the differences between unconnected connected lookup, differences between dynamic and static lookup cache, lookup performance. This is also very important. Okay, so all are important. Nobody may be asking you what is a lookup and what are the uses of lookup. That is like a silly question. But even after my 15 years of experience and recent interview, they were asking about what is a lookup. So it depends on interviewer. If interviewer is experienced guy in Informatica, they won't ask because they know that it's the basic. If somebody is getting interview questions from Informatica, interview questions from internet, then they will be asking all these silly questions. Okay, so last three are the main ones. Okay, others you just anyway have to look into what is a lookup. Okay, let us start. Let us see what is a lookup. Okay, in theory. Okay, so lookup is a table or a file which is used in the mapping to get a related values or do some calculations and get a calculated value, and also see whether a target record is already existing in the lookup or not. I mean, what I mean say, a lookup is based on the target table. So, and this is to check whether a particular record coming from source is already existing in the target. If it's already existing, you do nothing. If it's not existing, then insert it. If it's already existing and there is a value change, then update it. It's usually a SCD type 2 or SCD table dimension table requirement to check whether it is existing already. If it is existing, then do this or do not. So that's why we do this. So there are three things here, okay, to catch it. One is get a related value without a calculation, and second one is get calculated value or derived value from the lookup. Third one is use in the SCD mapping to confirm whether the record is already existing, okay, or not. Okay. So lookup transformation can be either active transformation or a passive transformation. Active lookup means a lookup which gives you multiple records on a matching one record. Okay, that's an active lookup. Passive lookup, get only one matching relevant value, or if multiple matches are there, then you have an option to error it out. Okay, that is it. Passive means if a transformation input to the transformation and output to the transformation records are matching, then it's a passive. One record will come to a lookup, and getting the output is also one record from lookup is a passive lookup. Active lookup means if a source record matches to the lookup and lookup gives you multiple records for a particular match, then it's an active lookup. Okay, let us see more illustration in the next slides. Let us see how lookup works for getting a related value. Okay, so I have a source, okay, with the trade ID, trade description, and currency code. So okay, currency code I have. In target, I wanted to have the currency description for this currency code. So I have a lookup on a particular file or a table, which is a currency table, which has all currencies and their description. Okay. Now source record USD, go to this lookup and find the currency description and load it into the target. Okay. So this is one matched record found from the lookup case. Okay. Let us see getting a real calculated value or a derived value. Okay. How this works. I have a source trans ID, trans description, that's a loan. Okay. And I have a lookup with the same trans ID and loan amount and interest amount for that particular loan or particular transaction. Okay. What I wanted in target, it's a total amount I wanted. Total outstanding amount, loan amount plus interest amount is my total amount. So that is the calculation that I do. So getting a calculated value for a particular input. So trans ID 1001 is coming. The related value here is loan amount and interest amount. I'm summing these two up and then loading it to the target. So if one match record found here, okay, it's a calculated value. Let us see SED check whether a source record already existing in the target record or not. Okay. I have a source, customer ID, customer name, address coming from source. Okay. And my target already has that particular record yesterday loaded. Okay. So lookup is also on the target, so that's why this record is present in the lookup. So what you do, from source record it will find customer ID which is already existing. Depending on that, if doesn't exist, then insert into the target, otherwise you do nothing or you do update. Okay, so you have an expression after the lookup which decides what to do, or a router which will decide what to do, insert or update. It has to go. Okay, that is SED to check. Now I have a couple of more things to show you on a getting related value. Okay, so I have a source, trade ID, trade description, currency code, but unfortunately this currency code is not loaded into the lookup already. So lookup doesn't have any data. That means you forgot to load the currency lookup table. So now you are loading the source data into trade data into target. In such case, you will get null. So if USD currency code is not present in the lookup, the currency description will come as a null. Okay. So here I have three options. Okay. Null is a default value can come here, or for this particular column you can have a default value. When this is a connected lookup here, you can have a default value. So if you set up a default value for currency description, if lookup doesn't match any record, then it can return that there is a USD. So USD can come here. Okay. Or after this lookup you can have an expression, and if this lookup value, output value for this lookup is null, then do something else and put something unknown or UNK currency description. That is also possible. So there are three options you can do if no match record found. Let us see what we can do if we have multiple records matching. I have a source, same trade ID, trade description, currency code. I have a lookup. I have loaded currency multiple times, currency file multiple times loaded, so you got a duplicate there. Okay. And target, I am taking currency description as is. Okay, because there is no change in this one. What are the options you have if you have a multiple matched records found? Okay, so we have a first option, take the first record from the matched record set, or select the last record, or error it out. See, in this case all three are same, so I can select either first record or last record. There may be some cases where USD first record may be US dollar, second record may be USD dollar, something like different names are there. Then you are confused which one to take, right? So first record may not make sense, second record may not make sense. So in such case you will go with error. Okay, that's how it is. And let us see next example. So lookup basically can be of two types in the mapping. It's not actually types, but there are connected lookups and unconnected lookups. Connected lookup is in a mapping, if a lookup is connected, with arrow marks here. Connected, that is called connected lookup. If a lookup is not connected and it's a separate in the mapping without any input or output connections, it's an unconnected lookup. Okay. Let us see lookup passive example here. There is a source with employee number, employee name, department number. I have a lookup on department. Okay. So target, I am looking for employee key, employee number, employee name, and department name. Okay. So this is a passive example. Why? Because for every input record from table department, you are getting one output record. So 10 matching here and engineering come. For 101, 10 matching and one record only come. So it's a passive example. Let us say active example. I have a source with one particular employee number, employee name, address ID. I have a lookup. In target, okay, let us see the lookup. Okay, in lookup for the same employee and same address ID, I have three. One is house, office, and personal address. So three different addresses are there. So for every matching record, you have multiple matching records from lookup, and it can be loaded into target. So now the source is from source one record is coming to lookup, but from lookup you are getting three records. So that is the active example. Okay. So that is the input to lookup and output records lookup are not matching. That's why it is active lookup. This is very important question. Connected versus unconnected lookup differences. These are very important question. Okay. Let us see. Connected lookup. Connected lookup, as I told you, it receives input from pipeline, from different transformation. Okay. But unconnected lookup receives input from the result of a lookup expression. So in a particular expression transformation, you have to call the unconnected lookup as a function. So that's why this lookup LKP works. Okay, and that way you have to call that particular unconnected lookup. Okay, connected lookup, it can be using either static or dynamic cache, but in case of unconnected, it must be static. Okay, it can return multiple columns in a connected lookup, but in unconnected lookup, one column returning only. Okay, you can't return multiple values. Supports user defined default values in connected lookup and doesn't support the user default values. Okay, so if Indian interviewers asking questions about this one, connected unconnected lookup, then they will ask how to return multiple columns from unconnected lookup. Okay, see, both of these are two different purposes have been created, right? If unconnected you are using, then it only returns one column. Connected lookup, you will get multiple columns. If you want to get multiple columns, you can do it in the connected lookup, but he will ask particularly because sadist interviewers are there around the world, especially Indians. Okay, they wanted to prove that you don't know anything. Okay, don't be afraid, you have to answer in that. Okay, it can return only one column. Okay, if you want to return multiple columns, okay, you have to have SQL override with concatenation of multiple columns, and in expression you have to divide them into different columns. Okay, that is possible. Okay, so you can say like that. Okay, next one, what are the cache types we have? There is a static cache. Static cache is the default cache for every lookup, and the first record hitting to the lookup itself, it capture whole data from the table or a file, what is the lookup is, into a file called cache, and temporarily store it in Informatica server location, either Unix or Windows path, so that it can be referred quickly. Okay, this cache file will be deleted after successful run of the session. Okay, static means it won't modify the data once captured between session runs. Okay, that is static. Let us see the dynamic one. Dynamic cache. On the first hit itself, it captures whole data of the table and file into a file and temporarily store it in Informatica server location so that it can be referred quickly. So this is same. But dynamic means the data in the cache can be changed. Insert new records, update or delete existing records can happen, depends on the data availability or data change in the particular table. Say for example, you are looking up the target table itself. So first record is loaded into target table will be already inserted into cache automatically. It's not static cache, it's a dynamic cache. That means if it is loaded into targeted will be already refreshed in the cache. If you delete any record in the target table, target is our lookup, so lookup will be refreshed deleting that particular data. So that's why the changes can happen on the fly between session runs or in the same session run. So that's why it's a dynamic one. Third one is persistent. If lookup table doesn't change between session run, we can configure lookup as persistent cache so that we can reuse the cache file with other lookups in the same or different mapping. As I said, if once cache is created for static cache, it will be deleted once the session is successful run, right? In a particular mapping, you may be using multiple times the same lookup, or in different mappings or in different folders, you are using the same lookup again and again. In such case, why you want to recreate every time the lookup every time session runs, right? Instead of that, you can save this cache in the server location so that you can reuse it in multiple mappings or same mapping or different folders. So time can be saved and process can be improved. So that is a persistent cache we can do. So this helps to reuse the created cache instead of creating same data from table multiple times. This brings two more concepts. Okay, shared cache. Okay, that will be on the next slides. Shared cache. Unnamed cache and named cache. Okay. If a persistent cache is not named, then it cannot be used in multiple mappings. So it can be used in only in the same mapping. Okay. If you want to use it in multiple mappings, multiple folders, you have to name the cache. So if a persistent cache is named, the cache file that has been created can be named. That can be reused multiple times in the same mapping or other mappings in the same repository. Okay. When lookup transformation in a mapping have compatible caching structures, then integration service shares that particular cache. Let us see the lookup cache usage. Yeah. So let us see the usage of the dynamic cache. Okay. Dynamic cache can be used when there are frequent updates, insert, deletes are expected in lookup table, and you want to refer only recent data. Then dynamic cache can be used. Say for example, if you have a source with a lot of duplicate ID records, and you wanted to capture all data changes as a CD2 in the target table, then you need dynamic cache. Okay. Dynamic cache, as it suggests, it will modify the data every time. That means you have to scan whole this lookup file and update, insert, delete operations has to be done every time, every particular record. That's why it will be degrading the session performance. So for improving the session performance and all, you can't be using the dynamic cache if it is a use table. Okay. So let us see the cache type static example here. Case 1. If target doesn't have this record already, then what will happen? Okay. Static lookup on target table. Okay. So I have a source customer monthly coming data. Okay. Sriram is in address 123 Love Street on Lombard. On trans date, this one. This is monthly data. So it's February data. So that's why Sriram has multiple addresses here coming from the source file. Okay. There was no change in the customer address if you remember. Okay, lookup is empty. First time loading, so lookup is empty. Now what will happen? Duplicates will happen because it's not dynamic cache. Once cache is created, it has nothing. Okay, say for example 101 record inserted. Now second record is coming which is also 101, but lookup doesn't have any record because it's static. So duplicate will be loaded again. So all three will be loading again here. That is a duplicate here. Duplicate, all three duplicates will be loaded into target. Okay. Let us see what will happen if the particular record is already existing in target, loaded yesterday maybe. Okay. So let us see. I have a customer same monthly CSV file. Lookup has one record. Okay. Lookup has that particular 101 CRAM record. That's why target also has one. So that's why duplicates will not be loaded here. Okay. So no records will be loaded here. If you observe this, in static cache, it's inconsistent behavior if we have duplicates in source data with static cache. It depends on lookup whether it's empty or not, right? Let us see the dynamic cache here. Case 1, if target doesn't have this record already, then dynamic lookup on target table. We have a dynamic lookup on target table. Okay. So lookup is empty now. Once the 101 first record is loaded into the target, that will be refreshed into the lookup. So once first record is loaded into the target, the lookup is also on the target. That's why lookup is refreshed from empty to the same record. That's why no duplicate records will be loaded. Okay. Now use case. Let us see the use case. Okay. When to use which cache? Okay. Dynamic cache. If you want to capture cache data dynamically or you want to cache data up to date, you want the cache data up to date on each record, load to target. Okay, it's usually used in SE2 mapping but expensive in case of performance. Static cache. If you want to cache snapshot of a data, by default every lookup uses static cache. Say for example you have a currency file, currency table, that will never change. You can have a static cache for core data or base data. Okay, for trade transaction data, dynamic cache is expected. Okay, persistent cache. If you want to reuse the same lookup table cache multiple times in the same or multiple mappings, then you need persistent cache. Say for example currency. Customer dimension. Customer dimension has been used in fact tables, customer dimension, SCD2 tables, address tables, address mappings. So in such case, you have to use the customer multiple times. So instead of creating static cache, you will create a persistent cache and name it so that you can reuse it in multiple mappings. Let us see what is recache. At any particular point in time, your mapping is not behaving as expected. That means recent data is not updated into the lookup table. Or if you think currency data, say for example currency 250 currencies already there in the table, but 5 more recently added which are not there in the lookup, then you have to recache this one to get a new snapshot into the lookup file. Okay, that's recache can happen. Okay. Let's see some performance thing here. Lookup performance, which is also important, and you can also say it while interview. Okay. Lookup is expected to read and load data into a cache file from one or multiple table with a join in the OSQL override. Okay. If a huge table being cached, then it will be costly in case of performance. Okay. It will be slow. Okay. It will be slow. If a dynamic lookup cache is configured, a huge table, then it's too costly. Why I'm saying? Because it will degrade the performance. So to insert, update, delete every time, every record, it has to see in the target and it has to update in the cache file. So performance will be degraded. How to improve performance then? Let us see. Lookup is expected to read and load data into cache file from multiple table with a join, right? Lookup can have related condition to cache less number but needed records. Say for example, if I have a simple select star from customer lookup, that means it has to scan whole table and it has to take all 6 million data whatever customers we have into the file, right? So that is a bigger one, right? If you have a simple condition saying you want only USA people, then select star from customer where country is equal to USA, then that means you are reducing the a number of records to look up will be 100k instead of 60 million, right? So that way you can reduce the you can improve the performance here, okay, and reduce the lookup cache file size, okay. Lookup table can be partitioned so that we can only look up with one or couple of partitions instead of scanning the lookup, okay. There may be sometimes the second improvement task may not help sometimes, because even after you have a condition, you have multiple record more than whatever needed is coming, then it is useless to, of course it will improve somewhat performance but not 100%. So you need to partition the lookup table so that you will get more improvement, okay. Let us see with example here, because it's more of theoretical. Let me explain with an example. Performance tuning in current project. See, you have performance tuning techniques which is explained in the help document. First, you have to identify the bottlenecks: source bottleneck, target bottleneck, mapping bottleneck, session bottleneck, system bottleneck. You have to avoid them, and then you have to improve the performance, right? If you say all these things, you know that you only read the help document, but you didn't work in the current project, right? So instead of that, you give him some example of how to improve the performance. How did you improve the performance in the current project? Then they will be impressed. Let us see some examples here. As I told you, source bottleneck, target bottleneck, transformation bottleneck, mapel bottleneck, session bottleneck, system level bottleneck. These are the help document bottlenecks we have to be avoiding first, so that performance can be improved. While creating mapping, nobody bothers about this one because of they don't have time. Or if they have time also, they will do all these things at the last minute, so which is not feasible thing. So they don't do it basically. Okay, nobody will do it. Okay, let us see what we can explain what I did in the current project so that he'll be impressed. Okay, so case one, one of the dimension lookup, maybe trade dimension, is SCD2. It's running for 2 hours a day for 600k records processing. Okay, let us see how to improve the performance. Okay, the trade dimension caching 62 million records with a simple query, select star from trade dimension. Okay, because of that, it is using 98% of the resources, and it is scanning whole table and taking into a file, lookup file, which is also costly. Source records were less than what lookup is caching. Say for example, only 600k records are needed from source perspective, but it is scanning 62 million records, so which is costly. So now what I did, I added a filter in lookup condition. Okay, lookup select star from trade dimension, where um, quarter is equal to this one, or where year is equal to this one, where transaction date in between this, so that my 62 million will be 2 million. Okay, or 100k to 200k records being cached. Now my process is improved, and job is completing less than 30 minutes now. Okay, that is one of the way. Okay, let us go with the second example. I have a case 2 here. One of the mapping, say mapping you can say, or say some other mapping. Okay, mapping is taking longer time for getting status and updating a table. Okay, let me explain you better, because this statement may not be giving you full details. Okay, I have a mapping, okay, which have had HTTP transformation of third party web service. Okay, I have to send status. This HTTP transformation uses some jar file which is developed by Java developers. Okay, I never use it to see this transformation. Okay, so this HTTP transformation, if you call it, it will go run the execute the jar commands or jar script, and then send the status to a huge table in the third party table. Okay, now in ETL also I have to update the status as completed depending on what status from web service into my status table, ETL status table. Okay, ETL status is table is taking longer time because I have to read this third party huge table and select particular dates status, so which is taking longer time, and we don't have any keys on that particular table, and I'm not getting speed response from the third party table. Okay, what we can do here, right? So this mapping has two flows. One, to load the data, to extract the status from web service and put it in a huge table, insert only. Second flow, what is doing, I have to get the data from huge table for this particular transaction and get the status and load it into ETL table. Okay. Now what I did, as it has two flows, while inserting into huge table, I am also inserting the same record into a CSV file in my Informatica server location. So that in the second flow, I am only using that CSV file which has only one record, which improves the performance. Earlier it was running 45 minutes, now it is running less than 5 minutes. That's the improvement I did. Okay, you can say that. Let us see third case here. I have an SCD2 mapping, maybe trade dimension or customer dimension, whatever you want to say. Taking longer time to cache itself. It's a huge table. Itself means I have a same customer dimension target table, which is a same lookup cache table I have, and it's a huge. It's just taking longer time. Okay. So let us say it's a trade dimension only. Okay. Caching 62 million records with a query, 98% of the resource used. I hope you remembered this one. So it's case one only. I'm giving you second time. Okay. Don't simply assume it's a duplicate. It's a different way of solving this problem. Okay. So records from source are quarterly based. Okay. And needs only scan last a few quarters. Okay. What data I can expect from source is last 4 quarters only. Okay. Say for example in 2021 all 4 quarters I need to scan. It's a data warehouse. My dimension has 5 years of data. I don't want to scan whole table for 62 million records. What I have to do? Only last few quarters I want to do it. Let me show you what I did. Table is partitioned with year quarter number. Okay, that's a column. Year quarter is a column. And I have a condition in the lookup override to scan only that particular year quarter which comes from source. I use the same column into the lookup SQL override to have a condition to scan only that particular partitions. Partition means if a particular table is partitioned 4 partitions, then 4 different tables type of thing. So it scan only a particular partition. It won't scan whole table. It only scan particular partition. That's why scanning and getting the records into cache will be very easy, and it's a quicker one. Okay, instead of caching whole table, now the job is running in less than 30 minutes. Okay, that's how we can explain him. Okay, let us see what I explain here. I have a trade dimension here. Okay. Oh, okay. Sorry, I have explained this in better illustration. Okay, so I have trade dimension which is of 5 years of data. So year 1 also has 10 million, year 2 has also 10 million, year 3 also 10 million, like that. Okay, with a simple lookup select query, okay, I have to cache all these 50 million records into cache files. Okay, scan whole table, capture all records into cache, right? Now this process runs 2 hours. Okay, I think I have explained in better way. Earlier was theory and this is some practical type of thing so that you can easily remember this one. Okay, let us second case I tested. Okay, I told you. The second one is adding SQL query override in the lookup. Okay, let us see. So I have a same trade dimension. Sorry, I have same trade dimension. 5 years of data, 50 million records with a conditional lookup query here. Okay, so I have a lookup query override. Okay, now scan whole table, capture 25 million records only into cache because I have a conditional query. So only related values will be taken from 50 million. Only 25 million is needed now as per my conditional query. That means I improved session performance. Now it is running 1 hour, 50% I improved. Okay, it's not 100%. Okay, some customer managers or client managers won't agree with this one. They wanted the job to be completed in 10 minutes. Okay, everybody wants in 5 minutes only, but it depends on how much scanning it does, how much work it does in the mapping. Makes sense. Okay, let us see third one. Okay, so first case, it's a huge table scanning. Second case, huge table scanning, but is only fetching needed records only. Okay, now third third resolution step here, which can give us max performance improvement. I have a trade dimension with 5 years of data. Okay, I have partitioned table here. So year 1 is partitioned as quarter 1, quarter 2, quarter 3, quarter 4. Year 2, year 3, year 4 also partitioned, so that it can only scan that particular partition. Okay, so now I have a table partition lookup query override, which has to it doesn't need to scan whole table. It will only scan particular year or particular partition, and then cache that particular files. Now the cache file is very less, okay, very small, and scan only required partitions in table, capture 300k records, which improve the performance drastically, and now it is 15 minutes of run. So what do you understand? So there are ways to improve the performance. To get more performance improvement, then you have to think more different ways. Okay, sometimes in some tables you may not be able to partition them. Then the second option is the best one. Okay, likewise you have to decide which option is better. Sometimes DBA won't agree to partition it now because it's already 5 years of data and he doesn't want to partition now. Then we have to agree with 1 hour load. Okay, those type of things have to be carried out. Let us see next point. Informatica Power Center, pushdown optimization. Either push the source to source or target. Push the logic to source or target, or both sides. Okay, that is pushdown optimization. Let us see. As name suggests, pushing the logic here. Okay? It's just pushing logic either source side or target side or both sides. Okay. Source side optimization. Okay. Integration service starts reading the mapping logic from source towards target and prepares SQL query which can run against source database. Okay. And target side optimization. Integration service reads the mapping logic from target towards source and prepares SQL queries which can run against target database. Okay, I think it's a typo mistake. It's a typo. So it's a target database. Let us see in illustration. I have a simple mapping like this: source, source qualifier, aggregator, filter, update strategy, and target. Okay. So I have a source side optimization, how it will be done. Okay, let us see. Integration service start reading mapping logic from source qualifier, aggregator, filter. It will continue towards target and stops at a particular transformation where it can't push the logic to source. Update strategy has to happen on the target. That's why till update strategy it will read and prepare this select query and runs on the source side. So select column and you have an aggregator, that's why sum of column, and you have a filter, so where condition is there. Okay. Then after aggregator there is a filter, that's why I put like this. Okay, the query may be wrong, but integration service prepares its own query. Now let us see target side optimization. From target it will start reading till it reaches filter. Filter has to happen on the source records, not on the target records. So it will create an update query. Update set column 1 is equal to derivated column from filter and will load it into the target. This is target side optimization. You can use both two. We can use. Okay. When to use this pushdown optimization? It mostly used in simple to medium mappings only, where you have SCD2 mappings and all those stuff. Then you will not be using this pushdown optimization. Okay, where no other options for improving your simple mapping, then you need this pushdown optimization. Pushdown optimization is a separate license you have to buy from Informatica. If it is simple mapping, then integration service itself usually takes care of the load fastly. Or you can have a mapping level partitions in source target so that load is faster. Okay. In SED2 type of complex process mapping or more than 20 transformations in the mapping, nobody usually uses this PDO. Okay. We may not use this mostly because there are a lot of limitations and error handling cases which will create a problem for recovery of data. Okay, that's why pushdown optimization is not. In my 15 years experience, I never used this. I mean, any project I have used it. I have worked in different banking and retail projects, bigger ones, which no one uses the PDO. Why? Because there's error handling issues. Okay, when integration service pushes transformation logic to either source or target, it can't track errors. In Informatica, integration service can't track errors because the query simply push it to source or target. So if any errors occur in DB, then integration service won't track it. So that's the problem. When integration service configured full PDO and an error occur while execution, then DB handles the error. So integration service doesn't write reject rows in logs, so you will never know what record is rejected, what record is inserted. When integration service config full PDO and session fails, the integration service can't perform incremental recovery because DB process the transformation logic instead of DB rollback transaction. So there won't be any incremental recovery. There are specific database only which supports PDO, Oracle, DB2, Teradata, MySQL, Sybase. So because of these conditions, nobody want to use this pushdown optimization. Let us see some other limitations we have. If your mapping has normalizer, and if your mapping or expression uses parameter and variables, mapping parameter, mapping variables, then you can't push logic to either source or target. If your logic has a rank, then also you can't push the logic. When you have variable calculations in expression, you can't push. All functions you use in the mapping, Informatica functions, must match with source or target database functions. There are some functions which are differ from Informatica and database. So in such case, you have to find way to do it. If you use lookup for match, lookup conditions, if multiple matches found, then any value, then PDO will not work. You have to change it to report error. Yep. Sequence generator, sorter, if you have in the mapping, then it is not possible to use. With the special properties, you can use it, but source qualifier override not work until you enable a temporary view on the source qualifier. So there are some limitations in error handling, and these limitations, that's why nobody uses pushdown optimization. Let us see next concept. Informatica Power Center pipeline partition. Let us understand what is a partition. As name suggests, creating multiple load patterns so that bunch of records can process parallelly independently from the same source to improve the performance. A pipeline consists of there are some terms you have to understand, so a pipeline is also one of them. Pipeline consists of a source, source qualifier, transformation, target, nothing but a mapping. Okay, mapping is a pipeline. Okay. When integration service runs the session, it achieves high performance with partitioning the pipeline. Okay. Why? Because every pipeline uses ETL usually done in one particular, each partition in parallel. Okay. If you don't partition it, then it will extract the data from source 10,000 and start processing them. Okay. If you partition them, parallelly it can take multiple tens of thousands of records and process them parallelly. Okay. That way you will improve the performance. A partition is a pipeline stage that executes in a single read, write and transformation threads. Okay. say for example you have this partition, then one read, one write, one transformation thread will be created for processing this 10,000 k records every time. But if you have parallel thing, then multiple threads will be created parallelly. Let us see example after understanding the attributes. Okay, partition point is one of the attribute you have to set. Partition point marks the boundary, divides the, say for example this is the mapping you have or pipeline you have. Pipeline partition marks the boundary, okay, divides pipeline into stages. Okay, so there are two stages here. Okay, integration service redistribute rows at partition point. Okay, so stage is one of the partition point and target is one of the partition point here. So you have two partitions here. Now you have to set the number of partitions to how many number of partitions you want to do, either 5, 3, 10, you have to decide. Have to set number of partitions you want to make at stage. So from source qualifier you want to make it 5 parallel partitions, then 5 particular partitions will happen here and in target 2. Okay, let us see partition types. There are 6 partition types. One is database partition. The integration service reads partition instead of whole table. Okay, next one is key range partition. Integration service distribute rows based on a particular key you decide. Okay, third one, pass through. Integration service don't distribute rows. This is a default one you do. Okay, pass through. Round robin. Integration service distribute rows evenly among all partitions. Hash auto key. So integration service uses hash function with a particular key which you don't decide. It's an automatic take up. Okay. Hash user key. Same, integration service uses hash function, but you can decide a key. Okay. So let us see a mapping without a partition. Okay. So you have a source qualifier, expression, lookup, filter, and target. Okay. So you have a source and target database. Source 100k records are there. So if you don't partition it, 10,000 records for a particular commit transaction will happen. So each time it will simply extract 10,000 records and one read, one write, one transformation threads will be created and will load it into target. And then second piece will be taken. Second 10,000 will be taken. So if it happened like that, it will take 30 minutes. Okay, every time it only consider 10,000 records until it passes into target. Let us see an example of a mapping with 3 partitions. Okay. Now, 3 individual read, write, transformation threads will be created so that 10,000 records each partition can parallelly do at a time, so that you can improve the performance to 10 minutes now. Now this mapping can run at 10 minutes only instead of 30 minutes. Okay, you improve the performance. Let us see what are the limitations in the partition. One, as you know, round robin and hash auto keys, user can't be decided which key it has to use. Partition key can't be decided, okay, by the user. If you have a bitmap index and pass-through mapping, pass-through partition point you have used, then it may create a locking problems. Bitmap index may create a locking problem. I actually don't know in real time, but it is one of the thing that given in the Informatica book. Partition increases the DTM buffer memory requirement for job, because in a particular mapping without a partition, it creates one read, one write, one transformation threads to process 10k records only. Okay, DTM buffer memory will be adjusted there. But in case of multiple partitions, then buffer memory is more memory is needed. If your memory doesn't have enough space in there, then you will be getting memory full or memory failures, errors. Okay. So whenever you want to use partition, you have to increase your buffer memories, TTM buffering memories. Okay. Or you have to see whether everything is okay. Let us say aggregate transformation. This is the second transformation, which is also important in respect to the interview. An aggregated transformation lets you perform aggregate calculations such as sum, average, count, max, min, average, and all this stuff. Okay? It performs aggregate calculation when it reads the data, stores group data in index cache, and row data in a data cache in aggregate cache. Okay, cache is nothing but a particular temporary file that will be created by aggregated transformation for easy calculations, because it's like group. It has to group a particular column data until it completes the scanning of the whole table. That's why it has to put it in somewhere so that it can easily refer. Okay. Let us see an example. Okay, I have a source with customer name, deposited amount, and deposit date. Okay, so I have here I'm grouping customer names, and amount has to be calculated. Sum of amount I need it. Okay, so all group data, Sriram, Sita, Hanuman, are the group data which will be loaded into index cache, and its related values like index customer name and deposited amounts will also be cached, so that the while summing, the aggregator can use integration service can use both of these and sum up all the related values and load it into target. Okay, Sriram has some 6,000 amount summed up for January, and Sita has some 4,000, and Hanuman has some 6,000. Okay, got the point? Two important things to note to improve the performance of the aggregator, or aggregator, two important points which are important for interview too. One is incremental aggregation. Okay, when integration service performs incremental aggregation calculations, it passes new source data through mapping and uses historical cache data. The cache has been saved. Okay, for next time run, it will use the new source data. When no new source data coming, it will use the previous day's index and group index and data cache to do the calculations incrementally so that it can improve the performance. This allows the integration service to update the target incrementally rather than forcing it to process the entire data again. So history already there. So new source data is coming in, and you will simply use the historic cache to sum it up. Okay. Let us see usage of this incremental aggregation. Okay. If you want to capture new source data, then you have to use this incremental aggregation to improve the performance. Use incremental aggregation when the changes to the data doesn't significantly change the target. If processing the incrementally changed source alters more than 50% of the data, otherwise you will not be getting benefited from IA. What is this confusing thing, right? Simple. If your source data and target data, okay, here source data is there and you are aggregating something and loading into target. Okay, in target you have 100 records, source you have 50 records. Okay, only 25 records are being changed every time, then this incremental aggregation will help you to improve the performance. If you think 75 records are updating every day, then this won't help you in improving the performance. That's what it's saying there. Okay, if target has 100 records, I'm explaining again. If target has 100 records, source has 50 records only, but 25 records are only changing every day, then incremental aggregation will improve the performance, because it doesn't need to do all 100 it again. Instead, it will do only 25 and load it into target. It will improve the performance. If 75% of the records are being changing daily, then you don't see any improvement. Okay. In such case, what we have to do? You have to drop the table, target table, and do recalculation again and again. Okay. Let us see what is the important thing in aggregator second part. That is sorted input. Okay. With aggregator, with sorted input, integration service assumes all data which is input to this to aggregator is sorted by the group by port which is used in the aggregator to perform the aggregate calculation as it reads. Okay. Without sorted input, the integration service calculate as it reads. Since data is not sorted, integration service won't commit anything until it scan all the data to start aggregating. It won't aggregate the data. It won't commit any data into target until it reads all the data from table. Whereas with a sorted input, you already confirming that it's sorted input, and if three records are only coming from particular group, then it will sum it up and load it into target instead of scanning whole table. Okay, that way it can improve the performance. There are some limitations in the aggregator usage. Okay, if you have if your mapping has median or percentile logic in the aggregator, then you are not supposed to use incremental aggregation. Why? These functions use a system memory to process in addition to cache memory. In incremental aggregation, after completion of the aggregation for a particular day, it will store the last value into the memory. Okay. If you use median and percentile also, it has to use the system memory to process the addition of the cache memory. Then it's like integration service will be confused between these two memories and it will not be able to do proper calculations. So that's why, hence integration service don't store integrated incremental aggregation values for these functions. So it will be typical to make them sync. Okay, sorted input. If session is configured for incremental aggregation, then sorted input will not work. Why? When you select sorted input, the data will be sorted and last record will be stored in memory. If you read data on next day, then key value must be changing on which incremental aggregation work. So sorted input will be changing every time. Sorted input value and incremental aggregation value. So syncing these two will be a problem. That's why when you have sorted input, don't use incremental aggregation. When you have incremental aggregation, don't use sorted input. Okay. There are a couple of questions I have for you. Try to answer them. 1. What is the output from aggregator when you don't select any group by port column? What is the output from aggregator when you select a group by column but you didn't have any aggregate function? Then what will happen? What is the output? Okay, try to answer these. Let us see next topic, that is normalizer. This is also important topic. Okay. Let us see what normalizer is. What normalizer does? Normalizer is an active transformation. That means input to normalizer, input record count and target record count may not match. That's why it is an active one. Okay. Sorry, what is this one? Okay. You're getting the point, right? It's an active transformation. And it is used to transpose a record into multiple records or a particular column into multiple rows. Okay, that is normalizer. Let us see an example. To transpose a record into multiple records, normalizer can work like this. So say for example I have a source with store and quarter values. Okay, quarter sales. So store 100, quarter 1 is 100, quarter 2 is 200, like that. Okay. So now these quarters will be divided into rows here. Okay, the one particular row store 100 will be multiple multiple rows here. So store 100, quarter and sales day, quarter 1, quarter 2, quarter 3, quarter 3, here are the columns and now it become a rows here. Okay, this is possible with normalizer. Second scenario, it transpose columns into rows. Okay, say for example I have a trade source, trade number, error. So trade is a source file I'm getting. So errors are expected. So I have an error handling mapping which also handles that. So source, it will check for a particular input error records. Okay, and I have to send this file to source team so that they can send corrected data. Okay. So first record has two errors, E01, E02. These are the codes. Okay. Second trade also has three errors. Okay. So what my project requirement is that I have to create a file from this table with these two. Every particular record, how many errors we have, those many records you have to create. Say for example, I have two errors are there, then I have to create two records here. Okay, that way my error file will be perfect and I have to send it to source team for further validations. Okay, so I'm changing this column into multiple records here, of course. Okay, so this is the second scenario where we use normalizer. Let us see another example. I have a source with employee name, month, and transport expense amount, and house rent expense amount, and food expense amount. Okay. Now I have a target, employee name, month, expense type. Okay, see here, expense type, that is transport, house rent, and food, will be my expense report. Expense types and amounts will be calculated here. Okay. So in normalizer transformation, you have a normalizer tab in properties. You have to select these three. Occurrence level is important property to be selected. For employee name and a month, you don't need to do three rows for these two, right? So that's why you don't do. But in transport, house rent, food is becoming one column in target as a three rows, three occurrences. So that's why you have to say expense type as three. I give expense type name. You can give whatever name you want it to, or it depends on the target table. You can decide that particular name. Okay. So set of occurrences for three only will be deciding for expense type. Others will be as is one only. Okay. These are the setup properties you have to do in normalizer. Let us see example. I'm explaining more examples here so that you will understand better. I have a mapping source qualifier, normalizer, expression, and target. Okay. This is the source, employee name, month, transport, food, rent, expenses we have. I have a normalizer. I need to set what are the inputs that are coming from source qualifier. So I'm getting all these as is, right? So I'm getting all these as is. So I put all the columns as is and I have connected them. Now in the normalizer itself, I have to decide how many target columns are coming up. Okay. It depends on the target we have. Employee name is common, employee month is common, but these expense type, three columns will be becoming one expense type here. Okay. These three I'm getting amounts, so that is the amount I'm putting it here. Amount values only, right? These are three are the amount values, so amount values. GK expense type, GCID expense type are the keys generated by the normalizer for normalizer purposes. Okay, we will also use it in the expression to decide which column which amount is mapping. Okay, let us see. I have an expression here, okay, which I'm taking from a normalizer employee name, month, amount, GCID expense type only I'm taking. GK is generated key column for normalizer to use it. It's the inside use of it. If you want to use it, you can use it, but it's a key that has been created to identify the records. Okay. So I have a expression of expense type because expense type here only amount is there. I don't have the name of the expense type, right? So I have to create that one here. See, decode. I'm using GCID, generated sequence ID. Okay, generated column ID. Okay, so if generated column ID, normalizer will create all these numbers. Okay, this is generated key column from normalizer. Normalizer automatically create for every record. So one particular record it will give as one first record. So I'm naming it as a transport that is coming. Second one will be rent. Third one will be food. I have to give in this format so that I will get this expense type output, which needed for target will be proper. It will be accurate. Okay. See. So target is employee name, month, expense type, and expense amount. Expense type is not coming here. I have to create it depending on the GCID, GK, the GK generated column by the normalizer. So this is how you do in normalizer. So what is GK? GK is generate key generates sequence number for normalizer. GCID, generated column ID, holds value for occurrence of the particular field. 3 occurrences you sent. So 3 occurrences mean it will expense ID. GCID will give 1, 2, 3 which are needed for decoding, and you will give that expense type column. Okay. Let us see the next topic here. Differences. This is also very important thing. Okay. In the interview. Let us see first difference. Connected and unconnected lookup, which I already gave you earlier in the lookup section. Okay. Let me read it. Okay. Connected lookup receives input from pipeline. Unconnected lookup receives input from the result of a lookup expression in other transformation. Connected lookup, it can be static or dynamic cache, but unconnected lookup, it must be static. It can return multiple columns. It can return only one column. Supports user-defined default value. It doesn't support the user-defined value. Okay, let us see lookup versus joiner. There are some guys who will be asking these questions. Okay, let us see some examples of the lookup and joiner. SQL. Okay, lookup has SQL override possibility. You can have SQL override with a condition, multiple conditions. You can put all this stuff. In joiner, if you want to have a filter condition, then you have to use it in filter transformation before joiner so that you can filter it. Okay, lookup has SQL override, whereas joiner doesn't have SQL override. Multiple tables can be joined in lookup, whereas joiner, you can join only 2 tables. If you want to join multiple tables, then you need to use multiple joiners. In lookup, user can define cache, either static or dynamic, or what you want to use. Cache can be either static or dynamic. In joiner, cache is managed by the Informatica, so you have no option to select. Lookup is active or passive, whereas joiner is active. When a match in lookup found, user can decide you can take it as output as a first record or last record or all records you want to take or error that particular row. But in joiner is active, so returns all matched records here. So you don't have any option to select either first or last or all. Okay, so all is the default one. Let us see the difference between router and filter. Router divides the incoming records into multiple groups based on the condition. Filter restricts or blocks incoming records based on the condition. If condition doesn't match, it will block the records. If condition match, it will process the record. Router transformation itself doesn't block any record, but filter blocks it. If a source record doesn't satisfy any condition in the router, it will be routed to default group. There is a default group in router, so nothing will be blocked. You can forward these default group records into target or error file. Okay, whereas in filter you have no default groups. Okay, it will blocks the records which is not matching the condition. Router acts like a SQL case statement, whereas filter acts like a SQL where condition. Okay. There is a copy versus shortcut. Copy means it's an object copy. You are physically holding two copies of the same object. Informatica object. Copy is an Informatica object which is created multiple times in different folders with the same copy. That means it's a duplicate values. Okay, duplicate object. Whereas shortcut allows you to use metadata across folders. That means you create only one folder as a source, and you can use this source in multiple folders which can't be created a copy. It's not a duplicate, it's a reusable code. That way you can save the space. Let us see more about this. Shortcut has below advantages over copy. You can maintain a common repository objects in a single location. If you need to edit a particular object, you can edit object in only particular location. No need to edit. If it is a copy, then you have to edit everywhere, wherever it is used. Okay. You can restrict users to set up predefined metadata. Say for example, all these shortcuts are in one folder. You can give permission to only particular person, so that others won't disturb the object. Okay. It saves space in repository DB by keeping the single object and references from there itself instead of copy duplicate. Okay. There is one more important thing: bulk versus normal load. Okay. Bulk load. Bulk load improves the performance. it will load bulkily into the target, whereas normal load happens row by row based on the commit interval you have. Okay, 10,000 is the default one. Okay, what are the disadvantages of bulk loading? Okay, in case of bulk loading, integration service bypass the database log, redo logs, which speeds the performance. Okay, what is the disadvantage? Without DB log, the target database can't perform the rollback in case of failure. Okay, then there's a problem. As a result, you may not be able to recover the data in case of bulk. In case of normal, you can do all this. There's a TLB versus CBLO. TLP means target load plan. CBLO means constraint based load ordering. What are these? Let us say target load plan. You have this mapping, one mapping with 3 different flows in it. Okay. If you see, all are independent. Okay. And say for example, this source loading the target data, and this target is being used as a source for second flow and loading into target. This file will be used as source here for third flow. Okay. In this way, you want to decide which sequence this mapping has to run. So first is first, second is second, third is third. Or you can decide which way you want to start, which one to start first, which one to start last. That is target load plan. That means individual sources, individual targets, you can decide which one to go first. Okay. In constraint based load ordering, integration service takes care of foreign key relationship between the table. Okay. So you have only one source qualifier, but it is loading into 2 targets here. Okay. Earlier, 2 different flows. Now it only one flow, but 2 targets. In such case, department is independent, but employee is dependent on department. That's why department has to load first, then employee. Okay, department 10 data coming, then employee department both one record only, right? So 10 first it has to load it in the department. All other employees which are related to this particular department has to be loaded in EMP. Okay, in EMP department 20 will not load until department has that particular 20 because it has a foreign key relationship. If department 20 is not here in department but in employee it is being loaded, then is a problem, right? Foreign key relationship problem. So it will discard the data. That way, integration service will take care of this foreign key relationship, that is called constraint based load ordering, which is a property you will select in the session. Okay, session level property. Target load plan is in the mapping level property. Okay. That's it for this presentation, folks. I have third part 2, third and fourth parts, which will be coming soon. Okay, thanks for watching this video. Thanks for your patience. It's a little longer video. Okay, thank you. Have a good one.